Assalamualaikum. My name is Muhammad Hamzah bin Jamal Zaki and my registration number is 13 DEP 22F1007. And what I'm going to talk today is what field effect transistors such as FET. What is FET? The definition of FET is an unipolar electronic device that controls the flow of current using an electric field. Unipolar either holes or electrons. Electric field, just like a magnetic field attracts magnetic materials, and electric field attracts electrons. FET can be considered as a voltage controlled current source. FET has three terminals such as drain, source and gate. Construction. The figure shows the structure of a N-channel JFET as it is N-channel. The main current path will be the N substrate. The two P substrates are diffused into the N substrate on either side. The two P substrates are shorted together using metallic contacts, and it is the gate terminal. The drain and source terminals are connected as shown in the figure. That's pretty much all there is to the construction of JFET. And now we shall move on and look at how the JFET works. Typical connection of an N-channel JFET is shown in the figure as it is a PN junction. At the two gate terminals, we know that a depletion layer will be formed. Now imagine that a negative VGS gate source voltage is applied across the gate and source term, such as that the depletion layer will grow and completely block the channel. Now from this we get a very important value, that is the gate voltage at which the JFET becomes completely off. Alright, now let's just see the VDS equation. VDS, to follow the equation, VDS is equal to VGS minus VP. From the Kirchhoff's voltage law, we know that VGD at point A is equal to VGS minus VDS. Then from these two equations, we get VGS minus VDS is equal to VP. That is, VGD is equal to VP, or the off voltage. A will be at off state and B will be at a constant voltage due to the previous accumulation of charges. And thus we can say that for a constant VGS supply, VDS should be less than VGS minus VP, and further increase will result in a. From the inference of the previous slides, we can analyze the output characteristics of a PT. The curve can be divided into three parts. The ohmic region is when VDS is less than VGS minus VP, and then it enters the saturation region. Further increasing values will make the JFET to break down. The drain current in saturation region is given by the equation. ID is equal to IDSS multiplied with 1 minus VGS upon VP the whole square, where IDSS is equal to drain source saturation current. What is the comparison between FET and BJT? BJT has a current controlled current source, while FET has a voltage controlled current source. BJT have bipolar, while FET has unipolar. BJT has low input impedance, while FET has high input impedance. BJT higher power consumption, while FET lower power consumption. And lastly, BJT has low switching frequency, while FET has high switching frequency. And now that is all. Thank you very much.